All right, so today we're diving into the world of software development. You know how, sometimes websites or apps can feel really slow,
Oh, yeah.
especially when a ton of people are using them?
Hmm.
Well, imagine that, but on a massive scale, like millions of users.
Yeah.
That's the challenge that Atlassian faced with Jira Cloud. It's that, popular project management platform.
Right.
And we've got their blog post all teed up here, ready to go. And it is a super fascinating look at how they use something called Protobuf to give Jira Cloud a major speed boost.
That's right. So we're going to be looking at how Atlassian's developers tackled this performance challenge.
Okay.
And I think you'd be surprised, even if you're not a coder yourself, how much of this story you'll actually relate to.
Yeah.
It's all about problem solving, smart strategies, and then those aha moments
Yeah.
when the right solution just clicks into place.
Those are the best.
Yeah.
And speaking of aha moments, the results they achieved are pretty impressive.
Oh, yeah.
They're talking about using 75% less processing power and shrinking the data size by 80%.
Wow.
That's huge. So I'm really curious to understand how they pulled that off.
Well, it all started with the fact that Jira, like a lot of software applications, was initially built as a monolith.
Okay, a monolith.
Yeah.
That sounds kind of ominous.
It does, yeah.
So is that like a technical term?
It is.
Okay.
In software, a monolith means that everything is tightly intertwined
Okay.
in one giant code base. So imagine trying to renovate a house
All right.
where every single room is connected. There's no walls, there's no separations.
Oh, wow.
That's kind of what a monolith is like.
Right.
Any small change could have these unpredictable ripple effects
Yeah.
throughout the whole system.
Okay, so as Jira grew more popular, obviously the user base exploded, right?
Right.
So did that monolithic structure start to become a problem?
Yeah, exactly.
Mm.
I mean, just think about it. You have millions of users who are creating tasks,
Right.
updating projects, attaching files. All of that data has to be processed and then stored somewhere.
Of course.
So the monolith, it's like trying to squeeze, an ever-growing amount of traffic through a single narrow doorway.
Okay.
And eventually it's going to create a bottleneck.
It's going to get really backed up, yeah.
Yeah.
So how do you even start to fix a bottleneck like that? Did they try just optimizing the existing code?
So Atlassian had actually already implemented a lot of different optimization strategies.
Okay.
But they realized they needed a more fundamental change
Yeah.
to really address the scaling challenge.
Yeah.
And that's where the idea of the issue service came in.
The issue service. Okay. So is that like a separate team within Jira? What is that?
You could think of it that way, yeah.
Okay.
It's what's called a microservice.
Okay.
Essentially, it's a self-contained unit of software
Gotcha.
dedicated to just handling everything related to Jira issues.
Okay.
And this allows them to break down that monolithic structure,
Right.
and start creating a more modular system.
So instead of that one giant house, they started building smaller interconnected rooms.
Exactly.
Yeah. Okay, that makes sense.
Yeah.
But I can imagine that transitioning from a monolith to a microservice architecture, that's not just a flip of a switch, right?
No, you're absolutely right. It's not a simple thing to do.
Yeah.
They had to very carefully plan and execute this transition.
Right.
And it's all done in phases.
Okay.
And the whole time, they got to keep Jira Cloud running smoothly, right? For millions of users.
Yeah, no pressure.
Right.
So what did those phases look like?
So they started with phase 1.
Okay.
And that's where the issue service acted as a fast cache for issued data.
Okay.
So they give it like a temporary storage space
Okay.
that can quickly retrieve information that's accessed frequently.
Gotcha.
This helped them validate their new approach
Okay.
and start to demonstrate what are the potential performance gains they could get.
So like a trial run.
Kind of, yeah, like a proof of concept to see if this issue service could handle the load.
Okay, what came next?
All right, so in phase 2, they started writing issue data to both the issue service
Okay.
and to the original monolith. However, when they were reading the data, they were primarily reading it from the issue service.
Okay.
So they're slowly
Gotcha.
shifting more responsibility to the new system.
Yeah.
It was a very careful balancing act.
Right, so a gradual shift of power.
Exactly.
What's the end game?
So phase 3 is where the issue service really starts to shine.
Okay.
It becomes the single source of truth for all the issue data,
Right.
meaning all the other parts of Jira, they rely on the issue service
Okay.
for accurate and up-to-date information.
Yeah.
And that lays the foundation for a much more scalable and efficient system.
That's super fascinating.
Yeah.
But before we dive deeper into how they made all of this work, I'm curious about one thing. In that initial phase 1,
Right.
how did the issue service actually work? Can you kind of walk us through it a little bit?
Yeah, so imagine a Jira user
Mhm.
is looking at a specific issue. Jira monolith, it sends a request to the issue service. Hey, give me the data for this issue.
Okay.
Issue service first checks its cache.
Right, that temporary storage space.
Exactly. And if the data is there, boom, it sends it back to the monolith immediately.
Okay, so that's if the data is already cached,
Yeah.
but what if it's not?
So in those cases, the issue service has to go back to the original monoliths,
Right.
fetch the data, store a copy in its own cache for future requests, and then finally send it back to the monolith that initially asked for it.
Wow, okay, so even in this early phase, they were already like starting to optimize for speed by caching that most commonly accessed data.
Right.
Pretty clever. But I have to ask, why go through all this trouble in the first place? What was wrong with their original setup that made this issue service so necessary?
That's a great question. It brings us to one of the key technical challenges that they faced.
Okay.
And that was the way data was being formatted and transmitted within Jira.
Okay.
So initially they were using JSON.
JSON. Oh, okay. I feel like I've heard of that.
You probably have.
Yeah.
You might not know it by name, but you've definitely interacted with it.
Right.
JSON is a way to structure data,
Okay.
like the information in a spreadsheet or a contact list,
Gotcha.
so that computers can easily understand it and share it.
Right.
And it's used all over the web. But as Jira grew, it turned out that JSON wasn't really the most efficient choice for what they needed.
So JSON was the bottleneck.
Essentially, yeah.
Interesting. So the actual data formats have that much of an impact.
It's a huge impact. Yeah.
That's crazy. What did they end up choosing instead?
So after a lot of testing and benchmarking, they decided to switch to something called Protobuf.
Protobuf. I'm
Yeah.
not sure I've ever heard of that.
It stands for protocol buffers.
Okay.
And it's another way to structure and transmit data.
Gotcha.
But it's designed to be way more efficient than JSON,
Yeah.
especially when you're dealing with massive amounts of data.
So it's like they swapped out a regular delivery truck for a high-speed rail line or something.
Exactly, yeah.
Okay, makes sense. But what makes Protobuf so much faster?
Well, there are a few key advantages.
Okay.
First, Protobuf is much more compact than JSON.
Okay.
It can represent the same information
Yeah.
using a lot less space.
Yeah.
Which means less data needs to be sent back and forth.
Gotcha.
And second, it's faster to encode and decode,
Okay.
which is basically the process of converting data into a format that can be transmitted over a network.
So smaller packages and faster processing.
Yeah.
That's a winning combination. But switching data formats on a platform as big as Jira with millions of users, that sounds incredibly risky.
Yeah, it definitely was. And I mean, one wrong move and the whole system could have come crashing down.
Yeah, no kidding.
This migration had to be handled with extreme care to avoid disruptions.
Oh, for sure.
And that's exactly what we'll explore next time when we go into part 2. We'll talk all about that meticulous process that they used to switch to Protobuf without any downtime.
Can't wait. That sounds super interesting.
Yeah. Welcome back.
All right, so we've learned so much about the technical journey behind this migration from JSON to Protobuf.
Yeah.
I'm really curious to hear how did they actually manage to make that switch without, causing any problems for Jira's millions of users?
Yeah. It really is kind of like a high wire act.
Yeah.
But, it required very meticulous planning and execution. And remember how we talked about the issue service?
Right, that separate system.
It's more efficient
Yeah.
for handling all the issue data.
Yeah.
Well, that was a key part
Okay.
of making this whole transition seamless.
So it's like they were building this new engine while the car was still running.
Exactly.
Okay, so how did they make that switch without anyone even noticing?
So first, they created these new endpoints
Okay.
in both Jira and the issue service.
Okay.
Think of endpoints like specialized doorways
Okay.
designed to handle Protobuf data.
Okay, so they built these new doorways.
Right.
What's next?
Well, then they implemented this clever flag system.
Okay.
Imagine a set of switches, and they could flip these switches
Okay.
to control which logic was active,
Okay.
the old JSON way or the new Protobuf way.
Okay.
So they had 3 settings. Old,
Okay.
only the original JSON logic is running.
Gotcha.
Check.
Okay.
Both the old and new logic run side by side, so they could compare and see, if there's any inconsistencies.
Yeah.
And finally, new.
Okay.
Only the Protobuf logic was active.
So they had a safety net and a way to double check everything.
Exactly.
Okay.
This flag system allowed them to gradually roll out the changes, carefully monitoring every single step
Okay.
to make sure that everything was working perfectly. And remember, this is all happening while Jira is still live with millions of users hitting it.
Yeah, that's crazy to me. It's like swapping out the foundation of a skyscraper while people are still dancing inside.
It is, yeah.
But I mean, even with all this planning, they must have run into some unexpected challenges.
Oh, absolutely. And, no technology is perfect. And Protobuf definitely had its own um, quirks that they had to learn to work around.
Okay, like what?
So one of the first things they noticed
Okay.
was that Protobuf handles null values
Okay.
differently than JSON.
So for those of us who are not programmers, can you explain what null means?
Sure. So in databases and data structures,
Okay.
null basically means no value or like empty.
Okay.
In JSON, you explicitly say a value is null.
Right.
Protobuf handles it differently.
Okay.
If there's no data, you just don't include the field.
So instead of saying this field is empty, you just leave it out entirely.
Exactly.
Interesting. Did that cause any problems?
It was an adjustment,
Okay.
but they came up with a clever solution.
Okay.
So instead of using null, they just omitted fields
Okay.
that had no data.
Okay.
And then when they needed to read the data, they just reconstruct
Gotcha.
like a default empty field if it was missing.
So they basically worked around it by filling in the gaps as needed. Did this have any unexpected benefits?
Actually, yeah.
Oh, really?
By omitting the empty fields, they reduced the overall data size even further.
Wow.
It was like a little win
Okay.
to storage efficiency.
So they turned a challenge into an opportunity.
Yeah.
I like that. What other Protobuf peculiarities did they run into?
So another hurdle they had,
Yeah.
they were using Spring, which is a popular framework for
Okay.
building Java applications.
Okay.
And Spring has its own way of handling errors.
Okay.
And it wasn't totally compatible with Proto.
A framework clash.
Yeah, essentially.
How they resolve that?
They had to write some custom code
Okay.
that would bridge the gap between how Spring handles errors
Okay.
and Protobuf.
So a little bit of behind the scenes tweaking to smooth things out.
Yeah, exactly.
Cool.
Yeah.
It sounds like their developers were constantly problem solving this whole time.
For sure.
That's impressive. Was there anything else?
There was one more quirk with Protobuf that I found really interesting.
Okay.
So sometimes when Protobuf's default values were transmitted,
Mm-hmm.
they were interpreted as null
Okay.
on the receiving end.
That sounds like a recipe for disaster. How did they make sure the data was being interpreted correctly?
So they added some special handling
Okay.
in the issue service code
Okay.
to gracefully deal with these situations.
Gotcha.
Essentially, they taught the issue service to recognize, hey, even though this is null, it's actually representing a default value.
So they had to add some intelligence to the system
Right.
to prevent these misinterpretations.
Exactly.
Very cool. Were there any other unexpected roadblocks during this whole migration?
Yeah, actually, there was one more,
Okay.
and it involved Memcached.
Okay, Memcached. Remind me what that is again?
Sure, it's a high-performance distributed memory caching system.
Okay.
You can think of it like, a massive network
Okay.
of super fast storage lockers
Okay.
that hold frequently accessed data. And so that can really speed up applications
Okay.
because they have quick access to the information that they need the most.
Right. We talked about caching earlier.
Right.
So how did Memcached play into all of this?
Well, what was interesting was initially, even though Protobuf
Uh-huh.
significantly reduced the size of the data,
Right.
they actually started noticing
Okay.
that Memcache was evicting data more frequently.
Evicting data.
Yeah.
What does that mean?
It means it's removing data from the cache
Okay.
to make room for new data coming in.
Oh, okay.
So it's like clearing out space
Okay.
in those storage lockers
Yeah.
when they get too full.
Okay. But wouldn't smaller data mean that they need less space?
You would think, right?
Yeah.
But it turned out that the way Memcache manages memory was actually causing this.
Really?
Yeah. So Memcache organizes memory into these things called slabs
Okay.
and pages.
Okay.
So each page
Mm.
is like a fixed size chunk of memory.
Gotcha.
And slabs are collections of these pages
Oh, okay.
that are grouped by the size of data that they hold.
Okay, so they have this a very organized storage system.
Right.
How did that cause problems?
So the issue was that the JSON data, because it was larger,
Uh-huh.
it had already filled up specific slabs
Okay.
in a certain way.
Okay.
And so when the much smaller Protobuf data came along, it didn't really fit
Okay.
neatly into that existing structure.
So it's like trying to fit square blocks into round holes.
Yeah, pretty much.
Okay. And it just wasn't working.
Right.
So how did they address this?
So initially, they had to restart the whole Memcached cluster,
Wow.
one node at a time.
Okay.
This would force a reorganization of the memory.
So like a manual reset.
Kind of, yeah.
Okay.
And that actually confirmed their suspicions that the way the slabs were being allocated was the root of the problem.
But I'm sure they didn't want to have to like restart their whole caching system every time they made a change.
No, definitely not.
Was there a better fix for that?
Yeah, luckily there was.
Okay, good.
So in newer versions of Memcached, there's a config option called slab auto move.
Okay.
And this automatically rebalances pages between slabs.
Oh,
So
right.
make sure that the memory is used efficiently,
Okay.
even when the size of the data is changing dramatically.
That's much more elegant.
It is, yeah.
So after tackling all of these challenges, like, did it work? Did it actually make Jira Cloud faster?
The results were honestly undeniable.
Okay, what were they?
So they achieved a 75% reduction in Memcached CPU usage,
Wow. Okay.
80% reduction in data size,
That's huge.
and a significant speed boost in how fast it took to encode and decode the data.
Okay, those are impressive numbers, but what does that actually mean for a normal Jira user? Like, did they notice the difference?
Yeah, absolutely.
Okay.
They actually saw a 20% improvement in Jira's server-side response time.
So what does that mean exactly?
So like pages load faster,
Okay.
searches, return the results more quickly.
Okay.
And the whole experience just feels like snappier and more responsive.
Right, so it's actually noticeable.
Exactly.
I like that.
And the really cool thing about this approach
Yeah.
is that all of these improvements, they actually compound
Okay.
as the issue service starts handling more traffic
Gotcha.
and more data.
So it's a scalable solution that, like, gets even better over time.
Exactly.
I love that. That's awesome. So what we've learned here is that these seemingly small technical choices, like changing data formats, can have a really big impact
Absolutely.
on performance and, like, user experience.
Yeah, and that actually brings us to a really important point,
Okay.
which is that these seemingly small technical choices can have a really big impact.
Okay.
And that's something that we'll explore in part 3
Okay.
when we talk about, the broader implications of this migration and what lessons we can all take away from it, even if we're not, software engineers ourselves.
Awesome. I can't wait. Welcome back to the deep dive. We've been on this incredible journey, exploring how Atlassian supercharged Jira Cloud with that whole switch
Right.
from JSON to Protobuf.
It really is fascinating, just seeing how
Yeah.
innovation and optimization can really come together
Yeah.
and make a difference.
It's easy to get lost in, like, all the technical stuff, but I think there are some really big takeaways here, even for people who aren't, super technical.
Absolutely.
Yeah.
What stands out to you as the most significant, insight from all this?
I think for me, it's that thing about, always questioning, like, is this the best way to do it? And being willing to, like, experiment
Right.
with different approaches. Like Atlassian, they could have just stuck with JSON,
Yeah.
but they didn't. They recognized it wasn't working and, like, they actively looked for a better way.
Right. And that kind of forward thinking,
Yeah.
that's something we can all,
Yeah, totally.
learn from.
They didn't just, like, stumble upon Protobuf by accident. They, like, actually did the research and they really tested it all out.
They did their homework, yeah.
Yeah, and they weren't just looking at the immediate,
Right.
benefits. They were thinking about, like, long-term,
Scalability.
Yeah, exactly. So by fixing those bottlenecks, they were really setting themselves up for success down the line.
Yeah. And it just shows how technology is always changing. What works now
Right.
might not be the best tomorrow. So you got to stay informed and, like, be open to these new ideas.
Yeah, and be willing to adapt.
Yeah.
It's kind of wild how some of the most important improvements
Uh-huh.
come from focusing on the little things,
Yeah. Absolutely.
It's like we always think about these, like, big, huge innovations,
Yeah.
but it's often, like, optimizing those, like, core pieces.
Yeah, the foundation.
Yeah, that makes the biggest difference. That attention to detail, it's, like,
Yeah.
huge. We can all learn from that.
Totally.
Yeah.
And I mean, we can apply that to anything,
Yeah,
not just software.
totally.
Right.
It's about, like, just always asking that question, is there a better way?
Yeah, yeah.
And then, like, actually going and exploring the different options.
Exactly.
I really like Atlassian's story because it shows what happens when you have that, like, culture of always wanting to improve.
Right. Yeah, and they managed to make things better for millions of users.
Yeah, exactly. Well, I think this has been a super insightful deep dive.
I think so too.
So what's, like, the one thing you want our listeners to really remember?
I think the big takeaway here is don't be afraid to, challenge your assumptions and try out new ideas
Yeah,
and like always be looking for ways to make things better no matter how small they seem.
absolutely.
That's how you stay ahead
Yeah.
and like get those amazing results.
Awesome. Well, I think that's about it for today.
Yeah,
It's been a really fun conversation.
absolutely.
Hopefully everyone out there listening is like totally inspired to approach their work with this like new
Right?
spirit of like innovation.
Yeah,
Keep those brains buzzing, fellow knowledge seekers.
absolutely.